To explain the seeming contradictions between particle and wave behavior, and also the impossibility of measuring certain quantities simultaneously with perfect accuracy, and that of course was the Heisenberg uncertainty principle, Erwin Schrodinger developed the wave function, which is the Greek letter psi, in 1926. Significant work was also done by Paul Dirac, and the two gentlemen shared the Nobel Prize for Physics in 1933. In classical physics, or Newtonian physics, if all the forces on an object, that's the key, all the forces on an object are known, you can find everything else, such as position, momentum, acceleration, etc. They can all be found. They can be found using the kinematics equations, the dynamics equations. We've also assumed we can measure things to an incredible precision and then predict exactly what is going to happen, again, based on the equations that were just mentioned. Things act very differently at the very small level of atoms. We have light, which is described as a wave in a particle. We have electrons being described as a wave in a particle. And we have Heisenberg telling us there is a limit to how precisely we can measure position, momentum, energy, and time. Schrodinger conceived the idea of the wave function. This wave function is assigned to electrons in light, and they have very specific wave functions. And this performs a similar role to that of force in classical physics. If you know the forces on an object, you can tell its velocity, acceleration, other factors like that. The wave function does the same thing for these very tiny particles and light. There is a major difference, and it's underlined right over here. You can no longer exactly predict what is going to happen. You can only give the probability of something that is going to happen. The key word, probability, not exact. How is the probability of a particle being in a certain position calculated from the wave function? A, the wave function is that probability. B, divide the wave function by 2. C, triple the wave function. D, square the wave function. This was first proposed by Max Born, and the answer is D, square the wave function.